Good afternoon, all of you. We were speaking about balancing the redox reactions, and in that, we spoke about half reaction method in acidic medium in the last class. And today, we will be speaking about half reaction method in alkaline medium to balance redox reactions. Before that, yesterday I had given a question to balance this equation in acidic medium. So first we will be solving this question, then we will move on to the alkaline medium type. So the first step, writing the equation, finding the oxidation numbers and finding which one is oxidized and which one is reduced. So this one Br2 is a native form, so it will have an oxidation state of 0. H2 is having same state. Oxygen, in this case, in a peroxide ion, it will show a -1 charge. H2, it will have 2 positive. O2 will have 2 negative. So one oxygen will have a charge of -1. And BrO3 in this case, 3 into 2 minus 2, it will be 6 minus. And 5 positive should be there to balance this. And H2O, oxygen, as we know, oxygen, the charge of oxygen in H2O is -2. So this is the oxidation states or oxidation numbers in this equation. Hence we can tell easily what is oxidized and what is reduced. So Br from 0 to +5, increase in oxidation state, hence it is oxidation, and oxygen -1 to -2. So decrease in oxidation number, hence it is reduction. That much we understood. So moving on to the second step, separate the equations into half reactions. So as it is half reaction method, we need to separate these reaction into two different halves, which is oxidation half and reduction half. And that equations will be, oxidation half equation will be Br2 gives BrO3 negative and reduction half will be H2O2 gives H2O. So oxidation half Br2 becoming BrO3 minus and the reduction half H2O2 becoming H2O. So this is the two half reactions. Now we are going to balance these two reactions and finally we will add them together. Moving on to the third step, balance the atoms other than oxygen and hydrogen. So first we will think about other atoms other than oxygen and hydrogen, then we will balance oxygen and hydrogen. So oxidation half and reduction half is there. In Br2 gives BrO3 negative. In this both sides, Br is having different number of atoms. In this place it is having 2 atoms, here it is having just 1 atom. So we need to balance that by adding a 2 here. So now both the sides we have 2 bromine atoms. And in this case H2O2 gives H2O. There is no other atoms than oxygen and hydrogen. So we don't have to do anything here. Moving on to the next step, where to balance the oxygen and hydrogen, oxygen by adding H2O and hydrogen by adding H plus ions. So oxygen we will see whether it is balanced or not. So in this Br2 gives 2 BrO3. Here we have 3 oxygens. 3 into 2 will become 6 oxygens. So 6 oxygens we need to balance here also. So add H2O to balance number of oxygens. How much ever oxygens we need, same number of oxygens, same number of H2O we can add to this side. So 6 oxygens we need, 6 H2O we can add. So we got 6 oxygen this side also. And in this reaction H2O2 gives H2O. Here we have 2 oxygens. And in this place we don't have 2 oxygens, we just have 1 oxygen. So one more H2O we add here. Hence 2 oxygens and here also 2 oxygens. Now the problem is balancing hydrogen. In this case 6 into 2. 12 hydrogens are there in this side. In this side we don't have hydrogen at all. So as it is acid medium, we are adding same number of H plus ions to this side. So this side we have 12 hydrogen, same number of H plus we will add to this side. Hence it will become 12 H plus. In this there are 2 hydrogens here, but here we have 4 hydrogen atoms. 2 H2Os are there, so hence 4 hydrogen are there. So 2 are remaining to come here. That we will add there plus 2 H plus. Hence oxygen and hydrogen is balanced in both the cases. And now moving on to the next step, where we need to balance the electrons or the charges. So in this side and this side we need to count the number of charges. Here we don't have any charge at all. But here, see, if you see here, negative charge is there. So two negative charges are there in BrO3 minus. So two BrO3 are there, 2 into negative charge. So two negative charges are there here, and here we have 12 positive charges. So 2 negative and 12 positive. Totally 10 positive charges are there in this side. So to neutralize that 10 positive charge, as we don't have any charge here, we have to make or we have to neutralize that 10 positive charge. Hence we can add 10 negative charges or 10 electrons to this side. 10 positive charges are there, so 10 electrons we are adding here. And in this place, here we have two H plus ions, and here there is no positive or there is no negative charge. Hence this place we need to neutralize this two positive charges. Hence we will add two negative charges or two electrons here. So it will become 2 electron negative plus 2 H plus. This step many of them have written it wrong. So please correct that. So 2 electrons plus 2 H plus H2O2 gives 2 H2O. And moving on to the next step, which is balancing the oxidation number of electrons and reduction number of electrons. So that's what we are going to do first. So in the oxidation part here, we have 10 electrons, and reduction part we have just 2 electrons. So to make this 2 electrons to 10 electrons, what we need to do? 2 to convert to 10, we need to multiply this 2 into 5. So 5 into 2, it will become 10 electrons. We can't multiply a single component of a reaction with any number. So we are multiplying the whole reaction with 5. So hence this equation will become 5 into 2, 10 electrons plus 10 hydrogen H plus 5 H2O2 plus 10 H2O. So that we will sum with this equation. So hence the equation will become 10 electron plus 10 H plus 5 H2O2 gives 10 H2O by multiplying into 5. So hence we got both the reactions balanced. First we balanced the atoms with other than H, hydrogen and oxygen. Then we balanced hydrogen and oxygen, and finally we balanced the number of charges. That's what we did. And now we can take the sum of the both reactions, the oxidation part and the reduction part, hence to get the final net reaction or the overall reaction. So taking the sum of these two reactions, and when we take the sum, we can cancel off the electrons in both the sides. In here we have reactant, in the reactant side we have 10 electrons, and here we have 10 electrons in the product side. So we can cancel off them, hence we will get a reaction like this. So Br2 plus 6H2O plus 10H plus 5H2O2. The reactant parts are added together. First the reactant part is added together, and then we are adding the product part together. BrO3 plus 12H plus 10H2O. Hence we get the overall reaction or overall balanced reaction. We can cancel off some factors here, but we are not doing it now. So this is the final equation, and how we will understand whether it is balanced or not. First we need to check the atoms. Br2 we have same number here, 2Br here, 2Br here, and oxygen here we have 6 and here we have 10. So total 16 oxygens are there, and if you see here 10 oxygen here and here we have 6. So totally here also 16 oxygens are there. And hydrogens, here we have 12 hydrogen, here we have 10 hydrogen, and here also we have 10. So total 12 plus 10 plus 10 will become 32. 32 oxygens are there. In this side we have 12 plus 20. Again we have 32 hydrogens. So hydrogen is also balanced. Now we need to see the charges. Here we have 10 positive charge. Here we have 12 positive and 2 minus. Hence both the sides we have 10 positive charges. So finally the equation is balanced. So whenever you get a reaction or a final reaction, you can check that whether it is right or wrong by calculating or counting the number of atoms in both the sides and number of charges both the sides. And you have to copy this to your notebook and take a rough sheet, and from the beginning you try to do it yourself and check it with the answer so that it will be clear for you. With this, we finish the acidic medium type. Moving on to the alkaline medium type of half reaction method. So for that, a single change is there in both the reactions. It is same, almost same like the acidic medium only. Here we have a very slight change from the acidic medium. So for a reaction in basic medium, first balance the atoms as we done in the acidic medium. So same thing we have to do. But before this last step, what we have to do is, for each H plus atom, equal number of OH minus ions should be added to both the sides. To both the sides, equal number of OH minus should be added so that we get an alkaline medium. This is the only change where we have in alkaline medium other than acid medium. So when we add H plus and OH in the same side, it will combine to form H2O. So as H2O is H and OH ions together, so finally we will get water ions in the product. So that's why we are adding same number of H plus and OH in both the sides. We will see an example now. MnO4 minus plus I minus gives MnO2 plus I2. Same step as we have done for the acidic medium we will do here. So finding the oxidation numbers of each atom and finding which one is oxidized and which one will be reduced. So MnO4 minus, 4 into 2 negative charges are there, 4 into 2, 8 minus. 8 minus and a net negative charge. Hence we need 7 positive charges to balance that. 7 minus 8, which will become minus 1. I, as it is a single atomic ion, we don't have to find the oxidation number. The minus charge only is the oxidation number. So minus 1 is the oxidation number of I. Here MnO2 2 into minus 2, it will become 4 negative. So 4 negative, if we want to cancel off, we need 4 positive. So 4 plus minus 4 becomes 0. So as it is not having any net charge, it will become 0 only. And I2, in this case, it is having 0 oxidation state. So totally, what is the oxidation and reduction? Plus 7 to plus 4. So manganese decrease in its oxidation state. So we can tell it is reduction. And I minus, minus 1 to 0, increase in oxidation number. So minus 1 to 0, increase in oxidation number. Hence it is oxidation. And Mn, it is reduction. So the first step is completed. So the next step is separating them into oxidation half and reduction half. So in this, I minus to I2 will be the oxidation half and MnO4 minus to MnO2 will be the reduction half. So MnO4 minus to MnO2 and I minus to I2. And now what we have to do is balance the number of atoms other than oxygen and hydrogen. Same like we have done for the acid medium. Other than oxygen and hydrogen, whether the other atoms are balanced or not. In this case, single atom of I is there. In this case, we have 2 atoms of I. So for the balance that, we need to add a 2 to this side. So 2I gives I2. That is balanced. Here if you see, 1 atom of Mn, another 1 atom of Mn. So we don't have to balance anything here. And oxygen we will balance in the next step. So the second step is done. Moving on to the third step. In this step, we need to balance the number of oxygens and hydrogens. Here, as we don't have any oxygen or hydrogen, we don't have any work there. Here, in this place, we have 4 oxygen. Here, just we have 2 oxygens. So, adding H2O is the solution. Here, 2 atoms of oxygen is less. So, we are adding 2 H2O to this side. Now, oxygen is balanced. Now, we should see the number of hydrogen. Here we have 4 hydrogen, here we don't have any hydrogen. So 4 atoms of H plus we need to add here. So this step is also done. Till now we were doing it in the same method as we followed for the acid medium. Now the change in the alkaline medium comes. So the step which we told in the beginning, adding of OH negative. OH negative should be added in the alkaline medium now. So this step we don't have to add anything because there is no oxygen or no hydrogen we added. So that is fixed. Now change is for this step. So here, how much ever H plus ions are present, same number of OH negative should be added in the both the sides. So that is what this step tells us. How much ever H plus ions are there in the equation, same number of OH minus should be added in both the sides. So that we are going to do 4 H plus ions are there. Hence we are adding 4 OH minus here, not only here but even here. So same number of OH minus should be added to both the sides. This is the change from the acid medium. And we have told one more thing. If we add OH and H plus ions in the same side, it will combine to we get H2O atoms. So here we have 4H plus and 4OH minus. Hence we get MnO4 minus plus 4H2O plus gives MnO2 plus 2H2O plus 4OH minus. The same reaction. But here is the change. As we are adding same number of H plus and OH, we get combiningly we get H2O there. H plus and OH minus are combining to form H2O. And now we have 2H2O here and 4H2O here. We can cancel off two of them as there are in the two sides. So cancelling of 2H2O and 2H2O from here, we get MnO4 minus plus 2H2O gives MnO2 plus 4OH. So this is the equation after adding OH negatives. Now we need to balance the charges. Here we have one negative and in this side we don't have any negative. So adding a negative charge or an electron to this side, equation will be like this. And this place we have one negative here and 4 negatives here, 4 OH negative. So we have 4 negative here and 1 negative here. In that case, we need to add electrons to this side. So 3 electrons when we add, 3 plus 1, 4 electrons or 4 negative charges this side and even 4 negative charges this side. So both the sides charges are also balanced in oxidation part and the reduction part. So now the problem is, number of electrons in the oxidation part should be equal to the number of electrons in the reduction part. Here is 3 electrons and here we have 2 electrons. We cannot multiply any of this reaction with any number so that we get this, the same number. So what we are doing here is, we are multiplying both the equation with appropriate number so that this and this will be equal. So what we can do, if we multiply this with 3 and this with 2, we get equal number of electrons. If we multiply this with 3 and this with 2, this one will become 6 and this one also will become 6. So we are multiplying this number with this number and this electrons with this number. So we are exchanging and multiplying. So that 3 we are multiplying here and 2 we are multiplying here. Hence the equation will become 3 into 2i will become 6i minus gives 3i2 plus 6 electrons. And in this case 2 MnO4 plus 2 into 2 4H2O plus 2 into 6 electrons gives 2 MnO2 plus 8 OH minus. So like that equation will change. And now the last step, which is adding the reactions. So the equation becomes 6i minus plus 3i2 plus 6 electron. This is by multiplying with 3 and we multiply this equation with 2. So we got 2 MnO4 negative plus 4H2O plus 6 electrons gives 2 MnO2 plus 8 OH negative. Now the final part, which is summation. We are going to add the equations together to get our overall equation. And hence here also we can cancel off the electrons. So like that it will become 6i minus plus 2 MnO4 plus 4H2O. That will be the reactant part. And here in the product part, 3i2, 2 MnO2 and 8 OH is there. So totally equation will be like this. 2 MnO4 negative plus 4H2O plus 6i minus gives 3i2 plus 2 MnO2 plus 8 OH minus. So this is our final balanced equation. So now finally, to check whether this is correct, we need to count the number of atoms and number of charges in both the sides. So we'll start with Mn. We have 2 manganese here in this side, and this side also we have 2 manganese. And oxygen, we have 4 into 2, 8 here, and we have 4 here. So total 12 we have. And this side also 2 into 2, 4 are there, and here also we have 8. So 8 plus 4, 12. So 12 oxygens in both the sides. And if we count the hydrogen, 4 into 2, 8 hydrogens here, and here also we have 8 hydrogens. And iodine, 6 iodine is there. Here also we have 6 iodines. And charges, we have 2 negative charges here and 6 negative charges here. So total 6 plus 2, 8 negative charges are there in this side. Here if you see, we have 8 OH negative. So 8 net negative charges are there. So both the sides we have 8 negative charges. So all of them are balanced. So this is how we balance equations. We studied two methods in two mediums how to balance a redox reaction. So do practice the examples which are given in your textbook for better understanding. So please do that and submit. Thank you.